Okay, final attempt. My stream crashed again. There's no archive of this because I deleted the intermediary attempts. I tried streaming again twice after initially failed, explained, and that didn't work out. So I think my ISP is limiting my bitrate or throttling me or something. I actually don't know. That could be totally false, but we're going to give it one more try. If this doesn't work, I'm just going to kind of continue on and maybe try to configure the streaming later so that it actually works. Anyway, last it dropped, we were working on the at least 2 gate, and now I'm trying to connect input 2 to AND gate 5. So 1, 2, 3, 4, 5 is the layout. This, oh, looks like it reconnected. That's cool. It might have a hard time with the switcher. I mean, that could be it. Yeah, I just buffered for a second. It disconnected like it usually does, but then it said that the reconnection was successful this time. So let's see what happens. Let's see. Okay, let's just keep going. So gate 5. It is really distracting though, so I might take a break after this. Just kind of do this. Again, this is mostly for personal purposes. No one's watching the stream, so I just want to make this work. Okay. This is pushing it a little, but it works. Connected to gate 5. I think that's reasonable because there's only 2 inputs left, and they're mostly accessible from the right side. So let's try input 3, 2, 3, 6. Okay. So that would be 1, 2. This guy, 3, and so it actually alternates there in a nice little triangle. I'll illustrate that. We're trying to connect it to the AND gates in this structure. 2, 3, 6. 1, 2, 3, 4, 5, 6. See how that works? Cool. So we're going to start with 2. This is where it gets funny because I kind of locked it in. I mean, it kind of just looks like we're going to have to go lower anyway. Let's try this to maintain that connection. Yeah, because right. So first, let's get that input connected to something. Right. Then we're gonna. Yeah, that is frustrating. I don't know why it was so much easier when it was more condensed. That's kind of a mystery to me. I guess it required less blocks. 1 is successfully connected. 2 is successfully connected. 3 is... I guess let's start with the easy ones. So I think to connect this, we're going to run a torch. I know, crazy. And then another torch to invert the inversion. So let's do boy. Let's try something more like this. Yeah. I feel like that makes more sense. It still really sucks, but okay, that's connected. Right. 3 is connected. Let's go with 6 because that's going to be piece of cake. At least it looks like. Wow, I just fall to the void. And then, yeah, 2's the hard one. So let's get started on that. We could grab a slab, throw that on here. build that up. Verifying that's not right. And then connecting it as such. So then we could take this cable. Yeah. Yeah. Or just like that. And then that doesn't need to be lowered anymore. Gosh, this is just a spaghetti factory. This is the spaghetti factory in Orange County. Yeah, I mean, it works. So get it to work and then optimize later. Premature optimization is the root of all evil, right? So it works. Now, I actually don't know which ones. I mean, I guess it's just the remaining ones, right? So 5, 6, and I forgot to mark when these were completed. So that's complete. That's not complete. That's complete. So all of these happen to have one connection. So yeah, it just needs the remaining ones. So luckily, this one's going to be really straightforward, right? And we just drop this down. It's kind of like at the start. Actually, it's exactly like the start. Okay, I'm going to check if my stream is still working. It is. It's kind of surprising. That works. And then, oh boy, connecting this one is going to be fun. I don't even know how that's going to work. Yeah. So you can't do this because the torch is going to catch. You could do this if this was a target block, but I'm trying to make it not because I have target blocks and black blocks stand for NOT gates. Yeah, this sucks. Just full disclosure, this sucks. I just kind of wanted it to work the first time. Okay, so the stream dropped. Kind of unbelievable that I keep disconnecting because my bitrate is really low. You know, it'd be crazy. No, that wouldn't work. Oh, well, actually. Oh, that would be so convoluted, but it just might work. So let's do a target block. I mean, that's rudimentary fix. Oh, but well, yeah, that's how we're connecting it. So nope, disconnect that. Is that a short circuit? Is that what that's supposed to indicate in Minecraft? Is that supposed to represent a short circuit? Oh, see what just happened there. Wait. Yeah, oh, true, because that's stupid. Because oh, well, you know what? Well, I don't even know if this helps, but it clears it a little bit. That still really complicates things. That works. Oh, what? We have multiple inputs on, I think, yeah. Let's get rid of those. Yeah, that's still 2, 3. It's just, oh my gosh, it's so bad. That's so bad. So then this one, where would that go? Here? How do you connect that? Oh my gosh, that's too good. I mean, that doesn't connect to anything, right? No. Still no. Oh, wait. Should I be so bold? No, that goes down. That goes down. Maybe I kind of let go of the stubbornness. No, I don't want to. That's why. Yeah, where was my switch? My switches were lower. My switches were lower, which actually changes things. So, you know what? What is it? Is it clear? No, it's fill. I think it's fill. I haven't played in years, but I think it's fill. So then if we did the second set of coordinates and then I did air, what do they have? Yes. Okay, that's what we're looking for. I know, it's crazy. We just nuked it, but we're going to do this again. You can't really optimize if you don't even have the initial design to begin with, right? So this isn't just for the sake of optimization. This is like, I actually think this worked better when this levers were on this level. So let's recreate those. I call them switches. I alternate between calling them switches and levers, so you'll just have to excuse me referring to this. Which honestly is a circuit in and of itself. Right, because people actually illustrate that. They make button switches, which would be fun to try to do that without any, without using the internet. I always try to do that. I push myself to do things like that, and then get really frustrated when I don't know. It's just like a problem I have. Zero grace. But it would be, yeah, it is cool. It is very fulfilling when you do it correctly. You know, we don't even actually need the fourth sign here because you can just guess. You could just guess the remaining ones. Okay, so 1, 2, and 4. So 1, 2, 1, 2, 3, 4. So these three. Honestly, this is a useful visualization if I just did this. Right? That's actually much better than this whole numerical system. So 1, 3, and 5 would be 1, 3. So it's all the top ones, right? 3, 4, 5, 6. I think I'm counting. I'm verifying because I feel like I don't think that's how I wired it last time. We'll do it. Yeah, do it that way. That's 2, 3, 6. I remember that shape. And then I think you just invert it like that? No, no way. I don't know. We'll guess that one as it comes. So now I don't believe myself. 1, 2, 3, 4. Yeah, okay. So how do we do it this time? It's always good to, you can always rip your own work. There's nothing wrong with that. Yeah, that is below, so we'll do that. And then we'll do this. See, simple, but there's compromises later. You don't know the consequences of these premature decisions. Sometimes you won't know, and that's okay. So now we connect to that one. See, this is where it gets funky. You see, you could use target blocks and like reduce this like crazy, but I just want to make it visually understandable. Like this is an AND gate, and these are like extraneous wires, right? But if I threw a bunch of target blocks in there, you kind of don't know what component is what. So it's like, oh, I can very clearly visualize this is, well, look at me looking at target block. But this is an AND gate because it has the same structure that I defined earlier. This is just wiring. You throw a bunch of different colors in there and then you get confused. Like if I really wanted to make a NOT gate, it would look like this. And then you can, obviously I use torches in my design for the wires and invert signals, but that's just for the sake of compactness. So if I have this, it's very easy to see that that is a NOT gate. So if I have an AND and a NOT, makes sense. But anyway, there's my little yap. Let's keep going. Okay. I mean, yeah, I don't really know what else to do. I guess to prepare, no, we don't want to go in lower. Okay. This one, bottom three. I mean, is that even true? That doesn't really make sense. Was that connected to the, no, I don't think so. Or top three. Oh. Yeah, that actually isn't as good of a system because you kind of have to lay it down. You have to account for relativity. It's like where things are in relation to it. So that grid, I mean, if you did a grid like this, well, no, I'm stupid. That actually works well. One, two, and four. So 1, 2, and 4. 1, 2, 3, 4. Yeah, so that should be like this. 1, 3, and 5. 1, 2, 3, 4, 5. Is that true? Let's check Turing Complete. Uh-oh. Is there no undo? Oh, we just nuked it. That's wrong, so that should be true. So, oh boy. Oh gosh. Wow. I can't remember. I mean, I guess we're just gonna trust this. If I did this correctly, we have all the data we need. So I just am really inclined not to trust this. Wow. Okay. I was right earlier. You need to account for relative position. I guess I would. Okay, the ones that haven't been touched. So that one, no, that has been touched. That hasn't been touched twice. Yeah, that one. Top right. Fill it with black as a work in progress. That one. Okay, let's do this systematically. That's been touched twice. That's been touched twice. That hasn't been touched. That's been, okay. Now, right. So then middle one, middle bottom. What was the first one? It was 1, 3, and 5. I'm getting confused because of these last ones, actually. That is 2, 3, 6. That is 1, 3, 5. That is 1, 2, 4. We just are going to have to trust the process. That's right. That one needs to power all the above. Literally. Temporary solution. To be changed later. 2, 3, and 6. How low did we... We did go lower. We went a lot lower. Off the get-go. We went a lot lower. I am okay with doing that. Never mind, I'm not. Yes, I am. Yes, I'm streaming with Minecraft music on because it's beautiful. I understand that that's going up. Double inversion. I guess you could say double knot is better. The last big Minecraft project I had was 1.16.5. Sure, some of you have seen that, which was Friday Night Craftin'. That's when I didn't really know anything about computer architecture. But yeah, I just haven't been around for the new music changes and everything. I was kind of like a 1.11 kid back in the day, so I'm just not keeping track with all these new Minecraft changes. Which is okay. I mean, I personally feel like Gen Z is old now, but... Or feeling the first symptoms of getting old. Namely, there's a generation ahead of you that is... that has a lot of new, different interests you don't entirely understand. Or just don't have the energy to really understand. You don't really care enough to do so. I have to remember, everything here is malleable. I'm really trying to power this. What a pain. Here's the clearest. You know what? Screw it. We're gonna go one block below. I am hereby expanding the range, because if I could do redstone dust up here, I should be able to do it. Have a block down here. End of discussion. Honestly, if I started with that, probably would have looked better, but let's just get this one done, because this is actually taking more. Well, you know what? This all takes a long time, so it's okay. That interferes with... No, it doesn't. Yes, it does. Look at that. Was that really how easy it was? Yeah. Don't even need a torch there. Don't need to do that. Don't even need a torch there. In fact, yeah. Well, no, I do need a torch because we're trying to invert it. Oh, and that's connected there too. Yeah, I definitely need that torch. So you just totally forgot the design there. So let's try this on. Everything else off. Yeah, I think so. There it is, ladies and gentlemen, 236. So now for the dreaded final boss. Also forgot to indicate that these were done. So honestly, let's do this so I can see. That doesn't do anything, but you know. Done, done, done. Yeah, so it really was this, which doesn't make much sense to me, but hey. So, baby redstone over here. Input, output stuff. Last torch is our target. This guy. I'm going to put dust there. What are the possibilities here? You know what? Nope, doesn't work because we have a torch there. What if I did something like this? Nope. Can I just route this through? Pretty sure I can. And yeah, I might have to block that off, but I'm sure some of you thought of that quicker. Okay. That's, you know what? It's a first version, so that's not even a correct illustration, is it? I have no idea. Frankly, I have no idea how this is laid out and if that even makes sense. The output, it's going to be pretty easy to wire this. So we can even go back to double trouble here and see the ores. So I need triple ores. I need triple ores. So that's a bigger and. Where's my bigger or? Here we are. Oh, that is just atrocious. That is just atrocious. Wow. There are your 3 inputs. Kind of burning out here. Let's try this. You know what's frustrating with cloning? I don't really know how it works. Or I do know how it works. I just don't like it. You can never predict. I'm making a lot of false statements. It's hard to visualize where it's going to go. So like, for example, oh, like I want to paste it here. That could go backwards, so I'm going to be really careful right now. I want to paste it here. Yep, it went backwards. Oh, that is scary. How many blocks is this wide? 1, 2, 2, 3, 4, 5, 6, 7. So let's say it was 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Yeah, it's actually not. We don't have enough room for it. I really think that that can be compacted more. I think we're gonna have to do that before. Like we don't have to, but this is just I totally filled that with air. But this is just no bueno. So here's what I do when I make a new version of something. I do this little or bar here, vertical bar. I know, hyper genius, 6 billion IQ. Okay. So we need our OR gates. I think that they can be right. You know what? Let's be bold. I feel like they could start there. I feel like they could be this close. Am I crazy? Okay, let me illustrate this. This is a bigger OR gate, so if any one of these are on, the output is also on. But you can also have them all on, or just 2 of them, or just 1 of them. But if it's basically it's only the output is only off if all 3 inputs are off. Okay, just to clarify. Okay. So these are NANDs. If you recall from the previous example, these are NANDs. I think now they're officially NANDs. Right. There's actually only 3 inputs here, so it's 1, 2, 3. We don't put an input there. So I'm gonna put no, I'm not gonna. I'm just gonna remember. Because yeah. So that has to be connected to that. So yeah, I feel like that is much more straightforward and more compact. So watch this. Boom. That's Well, okay. See, that's trouble because of that torch, which doesn't need to exist. Am I right? Does that need to be a not? So hear me out. No, that doesn't work. Hmm. You know what? What if we did that? As so, as such. Okay. But yeah, I think it's that torch. It can't be on. Am I going crazy? No, I think it can be. What did I just do? So I think I did this. Yeah, right? I think that makes sense. I see. I can't really work through the logic right now. I'm a little tired, but so it's initially connected to this torch on the purple block on the actual NAND. It's not connected to the NOT. This is representing the NOT, as I mentioned earlier. This is the start of the NAND, but an OR gate is composed of two NOTs and an AND, I believe. Let's cross-verify. Cross-reference. Yeah. So we have our OR gate here and then the modern iteration. Okay. So yeah, that's how you build an OR gate. So if it's just connected to a NOT, it works. It's just not really supposed to be how it works. It's supposed to be connected to one of the outputs of the NAND. I mean, supposed to, right? You know what's the benefit of this is, no, that complicates things. Let's just leave it as it is. See, who could tell me that this music isn't freaking drop dead gorgeous? It'd be kind of funny. I think for some strange reason that works. And it also centers that input for easier wiring. Yeah, so now we connect the outputs. I mean, that is an OR, ladies and gentlemen, a triple OR. Get it? I like that. So stupid. I guess this could be prettier, by just doing this. We need to lift this block, but we don't need to lift that one. I think it just looks better if you make it symmetrical, though. It's not really necessary, though, so it's easier to explain or understand if you have it that. I think that's a better, I mean, just, yeah, look at the difference there. This is, the middle input is offset to the left on this side. It's also longer, and they accomplish this. You could keep going with this. You could just compact it to nothing, but I think this is where we try it. Remember to get that one, because if you don't clone that additional level, you miss the dust here. It's kind of hard to, sometimes it's easy to forget. Because you're like, oh, I'm just cloning the blocks, but you're missing the redstone, and then you realize it doesn't work much later. So how wide is that? I think that's the same width, right? Yeah, that's the same width. It is still 7 blocks. Which is kind of necessary. So I think we might just have to expand this out, which breaks my heart, but I mean. So if we had, check this out. So let's say it had stress in here. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. This is 2 blocks out, which is kind of perfect because what you could do is do this carefully. That is still 7 on each, but it's only exceeding one more block. And honestly, that barrier might work. Yeah. Yeah. I get the idea that this one's going to be a lot simpler. I would like to try it starting from here. How long is this? I copied it with the lever, I think. 1, 2, 3, 4, 5, 6, 7. Oh. See, that's funny. It is 7 by 7. Let's do 1, 2, 3, 4, 5, 6, 7. If I just cloned it here. Nope. Oh. So let's clone it there. If I'm remembering correctly, yep, that's right. Okay. 2 blocks of space, perfectly fine. I think we can manage. Here are our inputs. Now, this is where let's refer back to Turing Complete. So I have the first 3 ands connected to each output of the OR, and then same thing on the other ones. So first 3 in this case would actually be 1, 2, 3. So if we were to illustrate that, funnily enough, it's going to be just this first one and then inverted. So like that. Second one is inverted. Put those around, yeah. What did I do? That's not right. Okay. Each of these need to connect to an input. That doesn't really make, this one doesn't really make sense, but that's okay. So let's do this This is going to be just enough room. If this is what we need, it's going to be just enough room. And no more. It also can't be, we can't connect it like this, because then what I think is a short circuit. You connect what I think is a short circuit. No, that's actually kind of gold. That. 1. 2. Lovely. 3. Let's follow this same pattern somewhat. This one is coming out to be pretty nice. I mean, you know, decent. Okay, so actually I need to explain something. I'm sure I am using redstone logic from like 2011. There are a lot of new updates that have happened to Minecraft, especially with redstone. And I'm sure, for whatever reason, I'm sure that sculk sensors can be used to make these much more compact. But I'm trying to take this from an electrical engineering perspective where obviously you can't just send signals through the air in real life when you're doing electronics. So I'm trying to keep this as vanilla as possible, as pure as possible, so that this knowledge can translate to computer architecture. Because ultimately, the reason I'm doing this, 1, it's fun. 2, I needed a Minecraft project. 3, I want to understand computer architecture. I bought Turing Complete for that reason. It's fun, but the motivation is even greater if I could build it in Minecraft, because I love Minecraft. So, yeah, I don't know where I was going with that, but that's the idea. I think that's all connected. Yeah. So now let's just do the remaining. First input on the second OR, I think you would say. On the second triple OR, yeah. Yeah, this is going to work out. I can already see it. So just to make this symmetrical a little bit, we'll try to mirror it. Mirror the same thing. This would really suck if I got the mappings wrong in inputs and outputs, because then this won't work. But it would be really awesome if I did. Look at that. Not bad. I mean, that's comprehensible. This, different story. This, totally reasonable. You just have to do a little picking. So at this rate, I know I should keep these. I don't like them. I can't see it. That was stupid. Honestly, I should have done that, but here we are. So back to Turing Complete. They are connected to a final standard OR, which can be accomplished by just taking one of these. Oh, that's actually nice, because the output converges here. We don't have to take the centers of each side. So, gosh, that lamp sound was loud. Each input now maps to another OR. Actually, yeah, I'm going to drop that. I'm going to drop this lower so we can maintain some consistency with where the ORs start. The level at which the ORs are vertically on the z-axis. Okay. I think it's done. This is a little scary. I mean, it's already on. I don't really know why, but it's already on. I don't know if we had to... Am I missing something? It's at least 2, right? Oh, it's already not working. This is a little heartbreaking. Why is it on? What? Let's go look at the OR gate. Do you have to invert it again? Here is our OR. No, you don't. Those are supposed to be off by default. Why are they powered on? Because these aren't. Do AND gates have a torch at the end? Because that really changes it, but that should be an easy fix if they do. They do. They have a torch at the end. You don't just, you only connect the NAND directly. So this actually turns into, oh, this turns into something else entirely. Actually turns into this. I believe this should be a quick fix. Relatively, at least. Okay, unlocked a new memory. I remember we can use slabs for vertical routing, so let's try it somehow. Pretty sure we can do this. Oh boy. Oh gosh. Yeah, that's horrific. No. This is a little harder than I thought. Target blocks would make this easier. I'm being stubborn. Hey. That is frustrating. Dare I? If we want to be clinically insane, yeah, connecting these is a little annoying. I think I'll end the stream once I'm done with this problem, because this has taken me much longer than I initially expected. For the sake of the stream. I already have target. It's not even valid because me. Am I wrong? I'm sure you guys can see my problem here, right? The lower torches are infinitely harder to connect than the ones that are higher. Why did that work? Could I not do that over here? Well, now I can't. Too many conflicts going on. Let's just finish this off. That one we had to get creative, but I'm sure we could just use the same solution here. Yep. Pretty sure they're all connected now. Okay, the light's off, guys, so here we go. We're going to go through all these switches, try them individually. They should all not do anything to the output. Golden. Now let's try 1 and 2. Boom. There we go. Now we're going to just finish the sequence to make sure nothing, okay. Not hearing any burning or short circuiting. So let's try this. So 2 and 3. Boom. 3 and 4. Boom. 1 and 4. And there we have it, ladies and gentlemen. The double trouble level, or otherwise known as the at least 2, is finished. That is a monster. Let's wrap this. I can't believe that. Wow. If there was a failed version here, I close this off. I don't set it as the OR. I don't think I'm going to want to redo that unless I find miraculously some very much smaller way to do it. Like, yeah, you know what? We did it, guys. So that's enough to be proud of. Everything's centered too. Like the lamp is on this level. It doesn't exceed this low. So let's get the dimensions before we close. 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 7 by 18. It's nothing, you know, even, but it's cool. I'm proud of that. That's really neat. Thank you guys for tuning in. I'll probably close out the stream now, just to also test if everything worked out. Yeah, stay tuned if you're interested in more of these episodes. I'm going to go through the entirety of the Turing Complete game, so just keep that in mind. It's going to be slow, but I think it's worth it. And yeah, thank you guys again for tuning in. Really appreciate it. And take care.